We leave footprints on this planet, and when it comes to CO2, the smaller, the better. Carbon footprint. That's the total CO2 emissions produced directly or indirectly during the different phases of a product's life cycle. Steel has one too. How much CO2 is generated in its production? What happens after its useful life? And can steel help save CO2? Our case study, Aurich, in the far north, where it's really windy. Naturally, there are a lot of wind turbines here, and this is also where they are made, in Aurich by Enercon, Germany's largest wind turbine manufacturer. The wind energy on our planet would be sufficient to supply the world with electricity, so we naturally want to try and build as many wind turbines as possible, but we also need to increase efficiency. Together with Enercon, we have developed an electrical steel grade that precisely meets the requirements of the product, converting wind energy into as much electricity as possible. That's what these generators do. Strictly speaking, laminations made of non-oriented electrical steel from thyssenkrupp Steel Europe. The steel is developed and manufactured at the Bochum plant. Here, coils of electrical steel are stored in various thicknesses and widths, tailored to the laminations that will be produced from them. $50,000 tons of electrical steel is supplied to Enercon every year. Moving all this by road would require 2,200 trucks. But Enercon and thyssenkrupp have developed an alternative transport model. Everything is handled electronically, so there's no paper waste either. Our own rail company transports the material directly from the mill to the unloading point, here in Aurich. This ensures quality and security of supply here at STA, and also saves CO2, which makes us really happy. The circulating freight cars provided by Enercon enable flexible loading for us at thyssenkrupp. The peak period congestion involved in truck handling can be avoided, while the logistics chain reduces administrative workload, saves transport costs, and ultimately has a positive effect on our carbon footprint. In Aurich, the laminations that will later convert rotational energy into electricity in the generator are stamped from the electrical steel. The leftover steel is of course collected. Several tons accumulate every day, and it's not simply scrap, but a valuable raw material. For Enercon, it is important that we reprocess all the excess material. It is melted in our own foundry and reused in components for our wind turbines. The objective is not only to produce green energy, i.e. without CO2 emissions, but also to produce the turbines with minimal CO2 emissions. Recycling 100% of the steel in the foundry makes a valuable contribution to this. So non-oriented electrical steel turns out to be a precious metal when it comes to carbon footprint. The CO2 savings begin during manufacture of the electrical steel through the use of recycled scrap, saving resources and energy. The rest of the production process is also CO2 optimized. Transporting the electrical steel by rail reduces carbon emissions. The high efficiency of the electrical steel in the end product produces energy savings. At the end of the product life cycle, 100% recycling provides further environmental benefits. A good carbon footprint is made up of many steps leading in the right direction. We've already come a long way with Enercon. Now lots of wind turbines are generating lots of electricity using our steel and making a really small footprint.